Hello and welcome to a new video here on the Lötwig Fusel channel. Now in this video series C++ libraries, we're going to take a look at a new C++ library every week. In today's week, we're going to take a look at FMT, and FMT is an open source formatting library providing a fast and safe alternative to CSTD.io and C++ IO streams. And that's actually everything that you need to say about it. Now FMT is a really popular library. Many people are using it. I don't know how many stars do they have on GitHub, but probably a lot. Yeah, like 16.9k stars on GitHub, and yeah, basically it is a alternative way to using formatting on C++. They are kind of like going the way of C format strings. So on C we had printf, and printf would have like a format string. And what they are kind of like doing, they're taking the same concept but making a few modifications to it, making different format strings, and yeah, basically having a way more extensive and a way more capable and also fast library on that. And many other libraries are building on top of that. For example, spdlog, a library that we're going to take a look at next week, it builds on top of FMT to format the log messages. And yeah, basically what I would recommend is if you're writing a library and you need formatting, just basically use FMT. Or now, I mean, nowadays you also can use STD format. So basically FMT was there previously, and I think even like the developers of them, of the library here, they did really do something to get a C++ STD format in here. However, it is I think even a bit more capable than the STD format. This is why it's like still a relevant thing. Now they also have a homepage where they're talking a bit more about the project, but yeah, I wouldn't really go into too much detail here on how this works here on their homepage, because we don't like something that's not dark mode, right? So yeah. Now FMT can be downloaded from the webpage here, so they are having releases here. Ooh, they have something, yeah, we don't care. They have extensive release notes, seems like it. You can download it somewhere down there, like you know it from GitHub, right? You have the FMT zip, you have the source. I don't know how the actual binary or by distribution here comes. You can see that you get some includes, a few headers, and probably a straightaway list of C files. Yeah, so you can see that the C++ source files, there are just 3 source files, a few more header files. However, it is all still in a manageable way. It's not a too deep hierarchy. It is easy to integrate into your projects if you're doing this all manually. However, what I like to do is I always like to do and use Conan. Now you can see that FMT was released 2 days ago, the version 10. And if you're going to the Conan project, it's called FMT, you can also see that version 10 is already there. So you can see that they are really actively maintaining their Conan releases as well. I mean, there are a few libraries where other people are kind of like maintaining the Conan releases than the library, and sometimes they get out of sync, and then you need to trigger them and say, hey, can you update this? Or you need to go to the open source project that manages the Conan file, and you need to make sure that the latest Conan version is there as well, which is sometimes a bit tedious to do. However, in case of FMT, they are actively maintaining it, which is good. Alright, so let's get into Visual Studio Code. Let's close all that stuff from last week, and let's get started. Now, I already prepared a new MoxPP template. MoxPP is my GitHub template for Conan plus Premake 5 C++ projects. Now, if you're downloading or instantiating MoxPP, you're going to get all these files, and now I'm going to basically modify them so that we can use FMT for a demo application. Now, first of all, I go into my Conan file and I replace the temporary SPD log with my FMT requirement so that we can use FMT. We don't need the configure here, but I am not going to delete it. Next thing that I'm going to do is I'm going to go into the mox.lua file. Mox.lua file is the root configuration file. I'm going to call that one FMT because this is kind of like my name of the solution. I want to like try out FMT, so I name it FMT. Everything else does not need to be modified. Next thing that needs to be modified is the build.lua in the source folder, because currently it's called hello world. I'm gonna call this one fmt underscore example and remove the separate output name because it's the same. And that's everything that I need to do. After that, we are done. We can now get started and run the project. For that, I'm going to right click the folder, reveal or open in the integrated terminal it's called. And then I'm going to run the command mox init. Now, if you're on a PowerShell, you need to write /mox.bat init. I'm on a classical CMD, which can do it straight away. Now it's downloading and compiling FMT for my target system. See, it's using a CMake toolchain here. And yeah, at some point it's then gonna compile with MS build. There we go. It's gonna do the thing for debug and release. And when it's done, it is gonna generate the project for us, Visual Studio solution. And there we go, fmt.sln. Just going to type in fmt.sln and it's going to open up Microsoft Visual Studio and everything is going to be set up for using FMT. And that's kind of like the beauty of my template that I'm using. However, you can, of course, if you just want to play this around, integrate this into your own projects in your own way without package managing, with package managing. Depends on how you like it. I personally like my template. Alright, so you can see that the current code is not going to work because it's the demo for SPD log. Now to get this working, I am gonna include FMT. Now FMT is in the subfolder FMT, and then you're gonna have a few headers. And since we want to use formatting, we're gonna use format.h. There are separate headers for whatever you want to use. Format is the normal format. There is also a printf header that is something that we might also want to include. Let's maybe include this, and then let's include format. Normally, what you just need if you want to use basic SPD or not SPD log, if you want to use basic FMT printing, you just need format. I'm gonna show you when you need printf. Now, how to use FMT? Well, in general, it's quite simple. Everything is going to be in the FMT namespace, and there is a function called format, and the function format is going to format something. Now, you can see, of course, it's not going to work by default. We need some parameters. Now, the first parameter that we always need if we want to format something is the so-called format string. So as soon as I provide a format string, everything is good. Now, how do I write the format string? Well, basically, the format string is a normal string. So if I would format hello world, I would also get hello world. Now it's returning a std string. So std string text equals fmt format. And after formatting, I can then say cout, which needs the IO stream. And then I can output the text, and I'm gonna get a hello world message. That's kind of like the idea. Let's see if it's gonna be there. And you can see, there we go, we get a hello world message. Now, in general, what FMT format is going to do, it's going to format into a string, and the string is after that usable. However, FMT also provides a way to directly print without going over a string, and this is why we can include printf from FMT, because there is a FMT printf. So formatted print, and if I use fmt printf, it's working the same than format, but the only difference is it's not going to return a string. It's going to directly write that to the IO stream, so the cout. And there you go, we're gonna still get our hello world. Now, of course, this is not a really interesting format string. Let's greet the user. So instead of hello world, I want to greet the user. So hello and then the name of the user. In normal C++, you would have an std string name. Let's maybe say, yeah, that's my name here. And what you then would do is you would go std cout, you would say hello, then you would go name, then you would go with the exclamation mark, and you would be done. This is kind of like the normal, good old C++ style way of printing it. However, on FMT, it's working different. On FMT, it works with so-called formatting parameters. So what you are doing is you are always specifying the format, so the whole line that you want to print, and after that, you're going to append all the arguments. So what we want to do is we want to say hello. Then we want to kind of like placeholder have the name. And then we want to have the arguments as arguments to the function. So, ooh, that's not what I wanted to do. To have the name appended like that. Now, what is the way of telling FMT that there needs to be something in here? Well, they are using curly brackets. Curly brackets are not something that's used too common, so if I want to write curly brackets, I am going to do it like that, and then it shall print out the name. So if I run that, you can see that I get hello and the curly brackets. Now, why is that happening? Because I think I am on the wrong print. I think I just need the normal FMT print and not the FMT printf. Yeah, there we go. Now the normal printf mimics the C style. The C style printf, and we want to use the format style printing. So we want to use print instead of printf, even through the header is called printf. Haven't used print actually. To be honest, I haven't used print on FMT before the tutorial at all, because normally you don't need printing that. Normally you don't print directly to the console. You have a logging library in between, or you have your own console instances, especially if you're doing like business or game engine software. You have your own logging facades. You might use SPD log, and it's all then gonna go through the library and not gonna be printed by your application. However, for this tutorial, it's totally fine. Now, of course, another thing is that we can print everything that we like. So if I would like to print a number, this is, and then a number, it of course also works, right? I can just plainly input a number, in this case 8, and I'm gonna get this is 8. And there we go. Now, in general, FMT is a really, really powerful library. You just give it the curly brackets, and yeah, it's gonna format every variable that you have, every type. If I provide a floating point type here, it's also gonna format that one in some way, and it's basically gonna automatically format everything how you like it. Now, of course, there are modifiers to that. So the curly brackets themselves, they can be optional and they can be extended to do what you want. Now, how do you do it? Well, I don't know. And you also not gonna know. If you're only gonna know the stuff that you're gonna use recently. However, you need to know where to find it. And what I would recommend you is it's an FMT cheat sheet. Now you can find something here at hackingcpp.com/cpp/lib/fmt.html. If you scroll a bit down, you're going to find a FMT cheat sheet for printing and formatting, and a FMT cheat sheet for time and date formatting. So if you want to print like time and date, it shows you how it works there. But we care about FMT printed formatting. If you open that up, you're going to have a PNG with a high resolution, which allows you to correctly format stuff. Now, in general, what it does, it gives you a bit general information on how it works. For example, what you can also do, what I haven't used, is you can use your own indexing or naming. So, for example, here we can provide numbers, so 1 and 0 instead of these curly brackets. If I would use that, if I would use 0 and 1 in the same order, then they are kind of like displayed, then there's nothing that's going to change. If I do 0, 1, it's the same order that happens, and I'm going to get hello Ludwig, this is 8. However, if I change the order, it's basically gonna change the order of the parameters as well, because I'm basically gonna tell that the first curly bracket is the second parameter, and then I'm gonna get hello 8, this is Ludwig. So I can kind of like turn around the namings. Then what I can also do is I can use name of parameters. So name of parameters are kind of like similar to like Python named arguments. So instead of referencing numbers, I could say that this is the name and that this is the number, and then it tries to kind of like fit the name and the number. However, to fit the name of the number, we of course also need to name our arguments here. To name these, we need cd string format string literals. So to use these literals, according to the cheat sheet, we need to use the namespace FMT literals. Now, in general, using namespace is bad. However, for literals, there is no other way around than actually using them. However, you should never use them globally. Never use the literals globally. Use them always inside of functions or inside of classes. So using namespace FMT literals. And if I do it like that, I'm basically, yeah, like putting the ability of using named literals in here. Now, how do I specify them? Well, I'm going to specify them by providing a string and a underscore a. The underscore a is the FMT literal. We could even try to see what there are available. So there is just the underscore a literal for the parameters. So here, so underscore a, and what do you need there? Do you need an equal sign for the literal? Yeah. Underscore a equal name. That is kind of like the way of providing a name of that. Now, how does that work? Well, basically, the literal defines, if I would maybe peek that, we might be even to be able to see what's going on. Yeah, there you can see what's going on. The literal is actually a operator. It is an operator operating. No, is it? Is it not? However, it's kind of like converting nothing to a fixed a detail export fixed string, and then it's returning a ULD arg. Yeah, basically what it's doing some conversion, right? I would need to take a in-depth look how it works, but basically what it's doing, it is a operator that converts a string or a string view or whatever that is. If I provide here some name, it converts this into a separate type, and then you are calling the equal operator on the type, which again then is going to return a reference to that same type or even an instance to that same type. So basically what happens is it creates kind of like a new instance of a class parameter, and the parameter is then going to be assigned the value of name, and the parameter was crafted with that string here. So then we have kind of like the name and the value of the parameter, which then can be passed inside of the print function or the format function. So yeah, I can basically do it all day long with these literals. I can provide the name and the number in here like that with the underscore a, and then it basically works as well. I can prove that by maybe like switching them around so that they are in a different order, and then we kind of like have named parameters all the way around. And this is also a very powerful tool to be a bit more explicit, especially if you're having longer format strings, or yeah, the format strings are a bit more complicated than that. Now, what you can also do, you can also provide some specialization. So we have different type that can be, or different types that can be parsed by FMT. So for example, we have the type integer, we have the type floating point numbers, we have the type string, we have the type boolean, we have the type character, we have the type pointer values, and we have ranges and tuples. And all of these types can be parsed by or put in as arguments to format strings. Now, depending on the type, you're gonna get different ways of doing that. Now, for example, you can see that it always has a certain format. So we're always going to start with the ID. This is kind of like the name, the number, whatever we have. This is always the first parameter. Then you have a double point if you're not going to have an ID. So if this is empty, you're just going to have a double point here. And then after the double point, you're basically going to specify how you want to format it. Now, what you can specify is always like a fill character, how it's going to be filled, alignment, if it's left, right, or center aligned. You have a sign, which is not available for unsigned integers, so plus, minus, or I think this is called keep it the same. Now you have that all parameter, and if you're taking a look at this down here, if you're specifying b, which is kind of like going to the type here on the right, we can like format this into binary, decimal, octal, or hexadecimal. If you just specify b, it's going to be specified without the type. If you are doing hashtag x for example hexadecimal, it's going to say 0x, so with kind of like the specification that it is a hexadecimal. You can provide a width and the padding, so you can say like my padding is 0 and my width is 8, so hashtag 0 8x, for example, to specify like 8 hexadecimal digits. So 8 hexadecimal digits will mean like 32-bit integers, and you could use this to like format them around how you like them. I think on pointers it's maybe even a bit more featureful, because pointers are always like displayed at 0x. But you can also like yeah, fill this a bit up with like a line, width, and types here on pointers, and it's all kind of like, yeah, good to see. Now floating point numbers are a bit more complicated. You also have like fill, align, sign, alternative. I think alternative is then gonna specify, do we have a example? No, we even don't have an example, so I then can't tell you what is really going on. You can specify position. Yeah, you can specify a type with like fixed point, hexadecimal, I think, exponential, or the general type, so you can do many things. Same goes with strings, the field width, cutoff, and stuff like that, right? But in general, what you need to do, I don't want to like explain everything that's on the cheat sheet. What I want to make you aware of is that this cheat sheet allows you to see what's possible, also see what's possible with all the examples here, and then you can basically just use them, play around until you get what you want. I want to quickly show you the example how you could do this with hexadecimal, for example. So if we want to print our number hexadecimal, I would say that the number is gonna be um, hexadecimal. I do want to provide this with a hashtag. Then I want to have this with 16, so yeah, like 64-bit. And then I want to have a hexadecimal where I can use this lowercase or a smaller case x. If I use a capitalized x, it basically means that all of the hexadecimal characters, for example, like A, B, C, D, they are gonna be displayed in caps as well, and not in like lowercase. And if I do it like that, I would now expect that my number is shown on hexadecimal. And you can see that the number is shown on hexadecimal. However, as you can see, there are many spaces in between here. This is because we don't have a fill character. So if I also specify a fill character here, then it shall also like patch these. And now you can see that it's 0x, and then it's dash 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 dash, and many zeros. And as you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's kind of like also taking these into account. So it's kind of like the global width. So yeah, would be, would need to adapt these so that the other ones also have space in here. So 64, if you would do the math in general, the math that you can do is you need to know which number you want to have. For example, if you have a 64-bit number, so you're going to do if you have a 64-bit number, you're gonna have 64. Now, a hexadecimal character is always 4 bits, so divided by 4, which would mean in this case it's 16 hexadecimal digits, and then we have the 0x plus 2, and then you are on the 18. So this is kind of like the way on how you would do that, and then I can provide a big number. For example, STD. No, I don't want to zoom. Back to my original zoom, please. So I could use something like STD numerical limits of size t. Then I can say max, which is like the maximum number, and then I would expect everything to be 0xff, and there you go. It is 0xff. And what we could also try is we could try use a lowercase x. And if I use a lowercase x, I would expect the FFF to be also lowercase and the x to be also lowercase. So that's kind of like the idea. 0x, FFFFF, it is everything that you need. Now, if you want to have this matched around, so if you, for example, want to have 0x lowercase, but the other ones all capitalized, then you would need to do it like that. 018x. And without the hashtag, and then I can provide my own one. Of course, now the padding doesn't work because now the 0x is no longer included in this formatting group, so I would need to go back to 16, for example. And if I do it like that, we could get the general 0xff how I would like it. So if I would do hexadecimal, I would always like print it like that, and then it's fine. Totally fine. And this is basically why FMT is so powerful, because it is basically having one specifier, not these percentage and then ugly specifiers from C. You just have a way to do it really simple. And I think you can also do normal brackets if you do it like that. I think if I do them in a double way, they should, if I'm not mistaken, printing the normal ones. Yeah, there you go. So if you want to have normal curly brackets, you just provide them by having them doubled. And if they are doubled and they are getting another one that starts it, they are printing it in FMT as a normal curly bracket. So yeah, it is a quite powerful library. There's one more thing that I want to show you, and I want to show you formatting with dynamic data. So if I would have a void print lel, and print lel basically gets a const, or let's do it as a std string, reference. I mean, we should do then a const reference. F string, if we would have a format string, and we would have a text. And later on, what I want to do is I want to use cin to kind of like get the format string. So, and then I want to print this out. So fmt, what I want to do is fmt print. I want to use fmt print from f string. I want to print the, of course, these literals not going to work here. Let's bring them up here. And then I want to print this like that with like content, or let's call this one C, just to make it a bit more simpler. And then I want to print it like that. So that's kind of like the way that I want to do it. And then I want to have a std string. Let's call this one format. This is my std string that I want to read in. And what I'm gonna do is I am gonna use stdcin to read a format string, or actually I should use std getLine, stdcin format to get the whole line here. So get the line into format, and then I wanna like print lel from the format and hello. That's kind of like the thing that I want to do. Now, if I compile that, it's going to fail. It is going to fail, and it's going to say failure was caused by a read of variable outside its lifetime. See usage of fstring. Now, the problem is that these format strings need to be compile time evaluatable. So in general, what FMT is doing, it is speeding up the processing time by evaluating the format strings at compile time. And this doesn't work if we are doing it like that. If this string is variable, it doesn't no longer work. However, there's a way around it. So instead of the normal FMT print, what you want to use is the FMT vprint. Vprint is a special function that allows printing of runtime evaluatable strings. However, you can see that it's no longer working. I can no longer use the parameters, and this is because the parameters now need to be a format string. So there is a fmt make format args function, and this is basically the function that you want to call. So this is what you want to call. Instead of directly putting the arguments in there, you need to call the fmt make format args. This would also work templateable. So if I would make this a template, I would make a type name, or maybe let's show you that this is working before I make this templateable. But in general, the idea is that you can make the format arguments here. And if I would do that and now enter my format string, now my format string could be blah, 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 and I would get this one back without the data. The data, I called it C. So if I would rerun that and now say hello C, then you can say hello, can get hello, hello, because my content was also a hello exclamation mark. So you can see that it's now working at kind of like runtime. And what I would now be able to do as well is I could make this a template. So a template, and then a variating type name t, for example. And then I could provide, or not t, I like to call this one args. And then I could provide like args. And what I would then need to do is I would need to use the std make format arg here, and then to basically do that, unpack the arguments. No, if there is a proper way with std forward, maybe we could. Let's maybe use std forward. I'm not quite sure if they are compatible with that, but normally what you want to do is you would want to make this with std forward, because std forward is also like keeping all references and stuff that's in here. Forward might not be in here. I think forward is in utility. Is it? I mean, it seems like it is, maybe. And you could provide it in like here, and instead of then providing it in here, you could go for and use it in the way that you were familiar with it previously, and then you could provide like the formatting arguments here, and this should work. But I can't guarantee that. It's always with templates, you don't know it until it runs, or not until it runs, until it compiles. But you can see that it does compile, and this would like be the proper way of using it with forwarding. So the text is, and then I can provide like C, and then I would get like the text is hello. I could also provide maybe more formatting arguments. I could provide arguments like an optional, let's call this one O, and call this one optional. And this is the beauty of these name parameters. Oh, of course, I need to have an equal sign in between. And this is like the beauty of these optional arguments, is that they are really just optional, right? You can like, and this is the way why you would use, or why you want to use like named arguments, especially if you're doing like business class, business grade software. In, for example, user interactable software, you would kind of like provide a maybe even a static format string, or maybe a dynamic format string, and a dynamic format string that comes like from the user, and the user can provide like their custom display strings on a web UI, for example. So the user, or not the user, the administrator of a system could provide like one of these format strings, and you basically have all the parameters as named parameters, and then the user is just like in a web GUI at some point gonna specify it, and it's gonna specify like the greeting, and the greeting would be like C. And then in the brackets you would have some optional stuff, for example, and then I can like provide my whole own different way here. Oh, I provided C 2 times. This is also a thing with like named arguments, you can provide them 2 times, but I wanted to really provide the optional in here. And it works. And if I don't provide the optional, it's not a big deal. If I do not provide any argument, it's also not a big deal, right? It allows us to provide a dynamic string, and it's all like forwarded the proper way, right? And this is kind of like a nice thing, right? I could like even go further and maybe put that into the namespace. I don't know why they really do not have something like that inside of FMT, so that you're not needing to call like the make format args and stuff. But that is kind of like the way on how you do it. And make format args works in many ways. For example, if you also want to have like a dynamic length of parameter lists, you could also directly use these FMT F10 format args. I don't know if that's a non-versionized way of doing it. Is there a FMT format args? Yeah, there's also a normal one that you can use. So if you're writing your own function, you could write a void is noisy because it's writing some data, and then you could like provide the format args as an argument, and yeah, then work with them. I think you can even, no, you cannot push back to them. They can just be constructed, sadly. But then you can like later on provide them even in like a normal print. You can provide them later on. So it really is quite capable. The library, and the video turns out to be longer than I actually wanted to be, because I wanted to explain them quickly. However, FMT is a really powerful library, and you can do so many things with it. And if you are talking about formatting, then FMT is the library that you want to use. No way around it. Formatting equals you use FMT. All right then. Thank you for watching. I hope you enjoyed, and yeah, if you enjoyed, please make sure to leave a like and subscribe the channel. See you in the next video. Have a nice day. Bye.